Okay, well, welcome everybody. Thank you so much for joining us this evening for this virtual public meeting for the Pipers Creek Natural Drainage Systems Project. This is a Seattle Public Utilities led project that's in collaboration with the Seattle Department of Transportation. Before we get started, just wanted to go over a few of the logistics associated with this Zoom webinar. First, wanted to note that the webinar is going to be recorded so it can be posted on our project website for those who aren't able to join us this evening. If you would like to turn on captions, you can click the live transcript button. And all participants will be muted, but we encourage you to submit questions using the Q&A box throughout the presentation. And we have some time set aside at the end to go through and answer those. And if someone posts a question that you agree with, you can always give it a thumbs up and we'll start going through the most upvoted questions first. And then if you're joining us tonight just via phone or watching this recording after the fact, we will have a comment feedback form posted on our project website so you can submit feedback or questions that way as well. So to start, we just want to introduce our project team. My name is Jonathan Brown. I'm the project manager with Seattle Public Utilities, and I'll be your primary point of contact. I'm also joined by Thomas Hawk today, and he, along with Benjamin Barrett, are your North Seattle Drainage and Wastewater Capital Program representatives. We're also joined this evening by Brian Doherty and Samantha Mock from SDOT. Brian will talk a bit more about the SPU and SDOT collaboration later on in the presentation. And then we are also joined by our design consultant team, Nathan Polanski, Kathy Gwillem, and Justin Martin from MIG, Catherine Deers from PRR, and Robin Randalls as well from the Urban Space for People. So for tonight's agenda, we're going to cover the following items. The first three are very similar to what we presented back in November, which was the last time we had the opportunity to do one of these public webinars. So those will be pretty similar to what you've seen before, but we just feel like it's always important to go back through to remind ourselves why we're doing the project in the first place and what the problems are that we're trying to solve. And then from there, we'll give you an update on the project from the last time we had the chance to present to you and what our next steps are. And then at the end, we'll have time to answer questions. So first off, we'll start with the project background and goals. Again, this will be pretty similar to what we presented on before, so I'll probably move through these slides relatively quickly, but our November presentation is also still posted on our website if you're interested in going back and looking a little bit closer at that. So just starting at a very high level, as we all know, it rains a lot in this city. We have very beautiful lakes, creeks, waterways, and of course the Puget Sound. In a lot of our urban areas, water falls on the roadway pavement, collects a lot of pollution, and then drains directly to those creek systems. So right now we have more than 370 billion gallons of polluted water from urban areas that are carried into our water bodies by stormwater runoff every year. And so how are we addressing this problem? The city of Seattle has signed an agreement with the federal government called a consent decree with the Department of Ecology to clean up our stormwater. And this is called the Plan to Protect Seattle's Waterways. And as part of our regulatory compliance efforts for meeting this consent decree, SPU, Seattle Public Utilities, has developed this integrated plan. And the integrated plan is a comprehensive program and schedule for implementing projects and other measures to improve water quality in our waterways. And one of the main programs under this integrated plan is to build natural drainage systems in Seattle's creek basins. So this project, the Pipers Creek Natural Drainage System, or NDS project, is part of that integrated plan. As you may already know, we have other projects in Pipers Creek on 120th and 122nd east of Greenwood. We call that the Venema project. And we also have projects in Longfellow Creek and in Thornton Creek. So the focus of the Pipers NDS project specifically focusing on the Pipers project specifically, our initial study area shown in that orange box covered approximately 40 blocks in the Pipers Creek watershed, roughly bounded by Greenwood to the west, Evanston to the east, 115th to the south, and 130th to the north. As we've done our due diligence for reviewing the feasible space to retrofit within the right-of-way and kind of further delineating the Pipers Creek watershed boundary, we've refined that study area to be between Finney and Dayton, and then the northern boundary of the watershed, the Pipers Creek watershed, which is between 127th and 130th, all the way south to 115th. The goals for this project are to reduce pollution into our stormwater systems to meet our consent decree requirements. We want to improve the health of Pipers Creek. We also want to improve drainage, conveyance, and collection systems where there's localized flooding issues. We want to improve sidewalk and walkways and provide traffic calming where feasible. And we'll be accomplishing this through building these natural drainage systems, installing additional drainage improvements, installing landscaping and street trees, and installing those pedestrian improvements. Now just focusing a bit more on the natural drainage systems themselves and how they work. Really at the highest level, the natural drainage systems are human-made structures that are meant to emulate nature. So we want to build these depressions in the ground along the edge of the street with plants and special soils where water can drain into, get slowed down, contaminants can get removed before it gets discharged back into the creek and other waterways. Just a bit more zoomed in view of how these systems actually work. As you can see from the graphic, dirty roadway runoff will get collected into these natural drainage system depressions, where the water is slowed down and filtered through the plant material and then filtered through an engineered soil mix before it's collected in an underdrain pipe and conveyed to a deep well for infiltration. And we'll show that more on the next slide, the deep infiltration. So yeah, this graphic just shows, again, the natural drainage systems collecting the runoff, getting into the underdrain system, and then going to a maintenance structure that will have a pipe that injects that water deep below the ground, approximately 50 to 100 feet below the existing ground, so well below any basements or foundations. We also wanted to share what these natural drainage systems can look like across some different seasons. So the left image is from a natural drainage system constructed in the Ballard neighborhood, shown in the spring. We also have a picture in the middle there of that Venema project I mentioned east of Greenwood, also in the spring. And then we have a picture of a High Point project in West Seattle from the fall and the winter. And it's also important to kind of share that these are living systems that will grow and mature over time. So the image to the left that you see is the planter strip, the typical planter strip that we will construct these natural drainage system cells in. And then moving left to right, you will see the newly planted cell, and then approximately 1 year after installation as they continue to grow in, and then finally after about 5 years when everything is fully matured. And now I'm going to hand it over to Nathan Polanski from MIG to talk a bit more about the project-specific updates that we have to share.
Thanks, Jonathan. Okay, you want to jump to the next slide. And so what we'd like to do is kind of give a little bit of an update on what we've been doing since we last talked to you in November, and share more information on the refined study area and focus moving forward. When we met last time, we had talked about the work that we had done to date. And just as a reminder, The city has performed a topographic survey, so they've gone out and identified all of the elements in the public right of way, where the street edges are, where the signs, the sidewalks that exist, and all that infrastructure. Over the last few years, the city has conducted soil testing. So they've installed monitoring wells in the neighborhood, and then done infiltration testing on those to identify how deep and where within that soil profile infiltration is possible. You may have seen a week and a half ago, I think it was, there was a drill rig on 115th between Finney and Dayton installing one more monitoring well. Our team has been out kind of observing the site during rain events and during non-rain events, kind of collecting data and kind of getting a better understanding of how the streets and kind of stormwater flows from a function standpoint. You may have encountered some of our team members conducting some door-to-door outreach last spring, and then the virtual meeting in November. So since that virtual meeting, we have evaluated the preliminary options that the team was looking at and selected blocks that will move forward into design. I mentioned the additional monitoring well installation. And since we last met, we met fairly soon after the Seattle Transportation Levy passed. And so SPU and SDOT have been working hard to establish that kind of partnership approach for this project so that there can be more complete infrastructure for people walking in the neighborhood. So looking forward, our next step is developing what's called the 30% design, sort of really confirming locations of individual natural drainage system cells along the blocks and coordinating with SDOT for sidewalk improvements and opportunities for traffic calming. Next slide. So for those of you that attended in November, we kind of talked through how we are identifying sites for natural drainage systems. And it's really based on the technical feasibility. So one, we need to find space that's available in the city's public right-of-way. And that depends on the type of street we're looking at. So a lot of the neighborhood are neighborhood yield streets, but there are also Dayton south of 125th is an arterial street. So there's different requirements for how that street will build out over time. And so we're looking at space that's available today and in the future as street improvements are implemented in the neighborhood. We're also looking at, and one of the most important things is, where is the drainage runoff collecting? And so we're really looking at the downstream end of those blocks. Below ground, the things that you may not be aware of and don't see, we need to make sure we understand where the utilities are. You can't, the city has requirements and kind of separation needs between water mains and natural drainage systems. And so we're looking at where the sewer is that's serving your house, where the water services are, the gas mains, all of those things, both the mains and the services to individual houses. And then coordinating with SDOT on their goals. So those are some of the key factors. We also want to protect and preserve mature trees and vegetation, and looking at parking patterns and kind of how people access their houses and parcels from a driveway and sidewalk standpoint. And then feedback that we gather through this community outreach process is informing suitability as well. Next slide. So here, I'm sure you are very familiar with the streets in your neighborhood. These are a few examples of the different blocks that we've been studying over the last year. A variety of conditions where you've got ditch and culverts in some places, gravel shoulders. Some places there's not a lot of drainage infrastructure. There's more ponding. Jonathan talked about the localized flooding or kind of ponding that happens in areas. And so a lot of different conditions, and we're taking that into account as we identified feasible sites and then also the kind of preferred solutions that we'll talk about tonight. So we're looking at two different types of natural drainage system cells for this project. One, and the kind of preferred approach to some extent, is the kind of standard graded cells, so that those two images on the left show a soft graded slope from the roadway down to that kind of depressed area where water can collect and sloping back up to what would be a future or new sidewalk. And below that, you can kind of see how that graded side slope looks like in a built condition. We're also looking at a cross section that could have a wall on one side along the sidewalk. So that center image shows a low wall that has a screen to provide a kind of vertical drop between the sidewalk and the planted area. And this would be designed with a special system that sort of supports the pavement system above. So in the graphic in the top right, you can see a little cartoon diagram, and there are soil cells that can be used. And so that drainage system can be designed so that it expands under the sidewalk, and you get a bigger footprint with that. And that can allow you to have less numbers of cells along the block. And so the city has done this in a few different locations on past projects. And so we're looking at both of these and trying to figure out what's the most appropriate for the neighborhood context, and also to meet SPU's goals for providing the water quality benefit. Jonathan mentioned the deep infiltration wells and kind of showed that graphic on the right. Since we last met with you, we've been working with our technical team members, kind of geotechnical engineers, to map the borings that have been done. So those monitoring wells that were installed, the geotechnical engineers took samples of the soil as that boring process was being conducted. And what we're able to do is map that soil below ground. And so that top layer that extends from about 30 to 50 feet below the ground level is very dense glacial till material that doesn't allow for water to be infiltrated. But below that, in that green layer in the middle, there's a more kind of receptive layer of sand and gravels to take infiltration. And so that zone between that dense kind of non-infiltrating red layer and where the regional groundwater and blue at the bottom is our sweet spot to provide the infiltration. So the types of changes that we're looking to make to the streets in your neighborhood, these are kind of simple cross sections that show how the street functions. The top one shows how the streets and the right-of-way work today. You have effectively, people are able to drive in two directions on your neighborhood streets, and most people tend to park on the shoulder, the gravel shoulder, but within the public right-of-way. And so we're looking and working with Seattle Public Utilities and SDOT to formalize that road width and sort of widen it to 25 feet so people can park on the street and have one lane of two-way travel, similar to other neighborhoods, I guess sort of south of the 80th or 85th neighborhood. We're looking at, like I said, two different types of natural drainage system cells. The middle section here shows the graded side slopes with cars parked on both sides of the street and one travel lane in the middle. And the bottom section shows how we might narrow the street to provide a curb extension. And so if you look at the picture in the bottom left, you can see a small curb extension that bumps out into the roadway, removes one or two parking stalls, and it allows more space for the natural drainage systems. The great thing about this type of, you get more area for natural drainage, but it also helps encourage people to drive slower along the street, particularly when you don't have on-street parking and it's happening, and you feel you've got a kind of 25-foot roadway. So those are the types of changes that we're looking to make to the existing streets. And everywhere where natural drainage systems are proposed, there will be sidewalks planned next to them. And the partnership with SDOT will extend those sidewalks, not just from the limits of the natural drainage systems, but for the full length of blocks. So these maps, when we met last time, we shared the map on the top, which showed the study area and the streets that were being considered with the preliminary options. After going through the evaluation, we've made some changes to the streets based on anticipated impacts to the neighborhood, and also from some of the other feasibility and in order to meet SPU's project goals. So we'll kind of talk first about the blocks that were removed. The next slide. So on Dayton Avenue, between 125th and 117th, those blocks were removed from our study area. Changes to Dayton would have resulted in removal of on-street parking. And so understanding and kind of recognizing the impact of the neighborhood there, after going through the evaluation with SPU, determined that improvements on those blocks were not of the most benefit. We also, on 117th between Finney and Greenwood, because of the impacts to the school and the church, both in terms of parking use and operations, and some of the other technical challenges based on the infrastructure and the grades that are there, those 4 blocks have been removed from our study area. As we removed those 4 blocks, SPU still needed to meet their goals for providing water quality treatment. And so we had to take a look at other opportunities where there may have been potential to provide that water quality treatment on the blocks that we hadn't been looking at previously. And so one additional block on 122nd between Finney and Greenwood has been added back into the study area as an opportunity to help meet SPU's goals based on technical feasibility of that street. So I mentioned, as we've narrowed down to specific blocks, going back to how do we decide where to put natural drainage system cells along a block. I talked earlier about the different kind of feasibility elements that go into that. And the key criteria are really, we want to put natural drainage systems where we're collecting stormwater. We want to put natural drainage systems where there's space available for them and we're not impacting driveways and trees. And then also where we're not impacting existing public infrastructure. So here are 2 little cartoons that we've developed to kind of show, in general, where a lot of the natural drainage systems will likely occur along the blocks. And they won't all occur this way, but in general, most of the blocks drain from north to south. So stormwater runoff is collected at the south end of the blocks along Finney and Dayton, and in general from east to west as it kind of drains down towards the sound. And so the lower half of the blocks are more likely. The existing water mains are located on the east side of the street, and they are in a location that on most blocks prevents us from locating natural drainage systems adjacent to the water main because we can't achieve the separation that's needed between those. And so generally those blocks, you see it on the west side of the street. And so when we look at what that means for the study area on the next slide, is that you kind of take those 2 graphics and combine them. In general, the natural drainage systems will be located on the southern end of blocks and on the west side of the streets. And you'll see on this map, north is oriented to the right. So 130th is at the right side of the screen, 115th at the left, and the green one on the top. But you can see a lot of those green lines are generally focused on the west side of the street and generally on the southern end of the block. Next slide. So with that, one of the things that we've been doing over the last month is really looking closely at how can we partner with SDOT. And so SDOT is really interested in providing continuous connections through the neighborhood with the transportation levy that passed in November. There's funding to provide sidewalk improvements throughout the city. And this became a great opportunity to kind of have city departments work together to provide the kind of more beneficial project to the neighborhood. About the areas that SDOT is focused on in terms of providing those neighborhood and community connections within our study area.
Thank you, Nathan. So I'm Brian Doherty. I'm with the Seattle Department of Transportation. I am in the Project Development Division, and I oversee our new sidewalks program, which, thanks to Seattle voters who approved the Seattle Transportation Levy last November, we have more money for new sidewalks in Seattle than we've ever had before. And so, as Nathan mentioned, what we would like to do is partner with SPU to maximize the positive impacts that this project will provide to your neighborhood by filling in the gaps between those green lines and provide a connected sidewalk network as part of this project, and also extend the limits to connect to the existing sidewalk network. Next slide. So for the last 20 years or so, we have been installing new sidewalks on Greenwood Avenue, and we are very close to completing those sidewalks. I'm really happy to say we're about at 60% design for the final phase of that work. And so the sidewalk network on Greenwood will be completed in roughly the same time period as this project. So we want to connect these new sidewalks that are being built on Finney and Dayton to the Greenwood sidewalks to provide a connected pedestrian network for pedestrians to access things like transit on Greenwood, the library, and also coordinating with the North 130th Street mobility improvements that are in design, and connecting people to things like Christ the King School and the Broadview Thompson K-8 School and the new Pinehurst Light Rail Station. So the project is building strong community connections for the Bitter Lake community to local services. Like I said, the library, Christ the King School, Pinehurst Light Rail Station. Funding for the project is going to be provided by the 2024 Transportation Levy. The funding for design was actually provided by the previous levy. We got to 60% design, but for Greenwood, so there's some funding from other sources, but for this project, it's going to be all from the Transportation Levy. Next slide. So SDOT and SPU have a long history of working together like this on successful projects. On the left, 12th Avenue Northeast and Pinehurst was completed about 5 years ago. And then on the right is 30th Avenue Northeast in Lake City. Those were both partnership projects where SPU installed natural drainage systems and SDOT installed sidewalk. We also know that there's a history of requests for traffic calming on these streets. We had a home zone project a few years ago where we heard a lot of interest in speed humps on these streets. The walkways and the natural drainage systems will narrow the roadway widths, which will provide a traffic calming effect and will slow down traffic. But we're also willing to look at additional traffic calming that we could potentially do as part of this project or shortly after this project is completed. So in order to support that evaluation, we're going to be doing some additional traffic counts on these streets and on the streets to the east. And that's it. Next steps.
Thank you, Brian. Appreciate that. All right, I will go through next steps, or where our project team's next steps are. So first, we just wanted to share our project timeline. So we've completed our options analysis phase and selected the blocks for NDS designs. So we will start to work on the engineering design for the NDS and the sidewalks. We'll continue with our community engagement, and we'll also continue to coordinate with SDOT on the design of sidewalk and walkway improvements beyond the NDS cells. In 2026, we'll continue and hopefully complete our design and permitting processes. We'll also continue with our community engagement with a focus on preparing the neighbors for construction. And construction is planned for late 2027 through the end of 2028. And then beyond that, SPU will be maintaining the natural drainage system cells. So again, SPU and SDOT will continue to partner on the design and implementation of the project to create a coordinated project. We also have a link here to our project website. We send out periodic emails through a listserv. So if you're interested in receiving those, please do go sign up on the website. And we also are very interested in continuing to gather feedback from you all. So please provide us questions in the chat box. We will also have a feedback form on our project website, and you can also just reach out to me as well. So there's a link to the website, and we also have the QR code that can be used as well that will direct you there. And then once this webinar ends, Zoom will also automatically redirect you to our project website.
Thanks, Jonathan. You ready for me to jump into questions?
Yeah, I think so.
So the first question we have is, has funding from the federal government been secured and on hand?
So from SPU's perspective, this is all funded through our ratepayer funds. So we don't have any federal funding requirements or restrictions to worry about. And I'll let Brian speak to the SDOT side of things.
Yeah, this will all be local funds. There won't be any federal funds. This is all coming from the transportation levy that was passed by Seattle voters last November.
Great, thanks. The next question is, who would be responsible for maintenance of the drainage? Is there funding established for long-term maintenance if SPU or SDOT is responsible?
Yes. SPU is responsible for the maintenance of the natural drainage system cells and any drainage infrastructure we install, and that is included in our funding moving forward.
And I'd just add, SPU sees these as infrastructure assets to them. So the same way that they take care of pipes and catch basins, they have to maintain these over time.
Great. From Victoria, we have, given the Dayton Ave portion that was removed from the drainage program, can we still expect sidewalks and roadway replacement? I'm disappointed to hear we were removed, but I understand the loss of parking at the barrier.
Which was the street segment?
The Dayton Avenue, 125th and 117th.
Yeah, so since there won't be any natural drainage systems there and there's existing sidewalk, we won't be installing new sidewalk. But if there are particular areas that are concerned with, I know that there's like no curb, for example, and if there's places where people are parking on the sidewalk, we could look at potentially putting some sort of barrier to prevent people from parking on the sidewalk.
Thanks. When will Dayton be paved if that's not part of this project? Do you have an answer to that, Brian? That may be for you again.
I don't. I'll have to look into that.
Another question about arterials. Can the arterial status on Dayton Avenue between 125th and 105th be changed to non-arterial?
That is currently under evaluation, and we will provide updates on that evaluation as part of this project. No decisions have been made now, but we are looking into it.
Do you know if sidewalks can be added west down to Carkeek Park, or who to ask about that?
Yeah, send me your specific locations and I can take a look at it. Basically, what I mean to say is, what route to Carkeek Park are you most interested in?
Great, thanks. We have one more. As you add sidewalks on the west side, what happens to the existing ditches?
That's a great question. We anticipate, I think, in many instances that accommodate the sidewalk and as the street gets widened for making sure that the stormwater is conveyed to the NDS hills. In some cases, or maybe many cases, those ditches would be replaced and runoff would be conveyed along the edge of the new street and kind of whatever that kind of curb edge treatment is, or thickened edge. But it may depend on sort of a case by case basis as we're going through. I know SPU in general likes or sees benefit in ditches in that they slow water down and filter water. But it will really depend on sort of the context of the blocks. But I imagine in many of the cases, those ditches would be replaced with planting strips and likely street trees in places where SDOT's putting sidewalk.
Awesome. Will mailboxes be moved during construction if they're in the line of sidewalks drainage systems?
Yes, mailboxes will be relocated. That coordination has to go through the post office postmaster. And so SPU and SDOT will work through that process and make sure that we're coordinating with homeowners prior to and during construction. And they would be shifted, generally end up landing between the edge of the street and the sidewalk.
Thank you. Parking on 120th is currently problematic with folks parking in front of the stop sign. How do we anticipate handling enforcement when parking becomes even more limited?
One of the things that we could employ in the design process are things like bulb outs that are at the close to the intersection that would sort of preclude parking in those areas in front of stop signs.
Yeah, so I think as we get farther in design and start to locate the specific cell locations, it'd be great to we'll take this comment and kind of document it as we move forward. But we will be having kind of more specific conversations with residents along the blocks where improvements are planned, and those are exactly the type of insights that are valuable to the team.
One last one so far. We have mature plantings that we believe will be removed as part of this project. How much time will we be given to consider our options?
Be working in advance of construction to notify residents where there are encroachments into the public right of way. So where there are plantings, or if it appears that there's sort of well kind of established and cared for planting in the right of way, we'll be doing our best to kind of contact those property owners through the design process and in advance of construction. I know Seattle Department of Transportation has a process for encroachments. And so where there are fences or other items that are located in the public right of way, there's a kind of process that they follow to have those items either removed by the property owner in advance of construction or moved by the contractor once construction starts.
That's the last question I have in the Q&A. Maybe we want to give people a couple seconds. I know the storm has arrived. I hear the thunder and lightning.
And if there are any follow-up questions or you feel like you kind of are interested in more information or detail on responses given, feel free to ask here or submit an email to Jonathan or through a comment card on the website.
Just give it a couple more minutes to make sure we got everything.
Regarding that comment about the plants and relocating the plants, we'll provide updates about the timeline as the project moves forward. And then once we have an idea when construction is likely to begin, that would be a good time to, because they'll want to be moved right in spring or fall for survivability, probably. And so coordinating with our construction updates and our timeline updates is probably a good idea.
Great, thank you. I don't see any more questions. Oh, one more. I have a sump pump in my crawl space because of groundwater which drains onto the street. How will this be dealt with?
So we do have, as we mentioned, Seattle Public Utilities has surveyed the entire public right of way for the study area. And so we should have those pipes that are discharging water into the street on our survey. I'm assuming that that's probably something that maybe discharges into a ditch just in order to get the water out. But for the pipes that are within our kind of improvement area, those would need to be connected within the public right of way to the future systems. And Nora, if you want to reach out with a direct comment to Jonathan, you're willing to share your address, we can look into the survey in front of your specific parcel and make sure that that drain that you've noted from your sump pump, we have surveyed as part of our survey file.
Great, thank you. Those were great questions. I don't see any more at this point.
Well, thank you so much, everybody, for joining us this evening. We look forward to talking to you more in the future.
Thank you all for taking the time out of your evening.